everybody, this is Mrs. Anderson, and we are headed back off into algebraic approach to limits, and this time we're going to do section 3. So in our first video, we talked about just plugging in the value, and in our second video that we just finished, we talked about factoring and canceling. Okay, so now the third one is what happens when we plug it in and we get a 0, not in both of them that like happened in section 2, but we only get a 0 on the bottom. Okay, so what does that exactly mean? So let's talk about it. When you find the value, so remember f of a means the y value. So I'm going to write that here, and I'm just going to try to focus a little bit better because I feel it's a little off. There you go. You get a k over 0, or you get k over 0 after factoring. So remember, k means a number over 0. Some value, okay, then this limit doesn't exist. So we're going to split our answer into two different limits. We're going to do it from the left, we're going to do it from the right. And then we're going to evaluate to see, are we getting a positive infinity or a negative infinity? And we're not just interested in the value of the value, we just want the sign. We want to know, are we going to positive or negative infinity? Only if these limits are either positive or negative infinity can we go and say that the limit is actually infinity or negative infinity. Now, what we've been doing is writing does not exist, and the reason is positive infinity, or does not exist, negative infinity. So it's important to say, we can say in either case that this doesn't exist. But remember, if it's a positive infinity for both, or a negative infinity, it's also true that it doesn't exist. But we can have it does not exist that doesn't necessarily mean that it's positive or negative infinity at all. The infinities could be going different directions, and we could get just different values overall when we split them up. So that's kind of what we're looking for, all right? So let's do some practice on that. So again, we're going to start, we'll put in our 2, and we're going to get, and sorry, let me start correctly to make sure we're all in the right habit. Even I will try to take shortcuts and have learned that when we learn it wrong, it's hard to undo it. So we have 2x plus 5, so 2 times 2 is 4 plus 5 is 9, and we're going to take our bottom as x approaches 2 of x minus 2, and we're going to get 0. So 9 over 0 follows this k over 0 number over 0. So now we need to do a little bit more, okay? So what we're going to do is we're going to look at the limit from the left. So we're going to say x equals 1.9, and we're going to say the limit as x approaches 2 from the left side. And we're going to have 2x plus 5 over x minus 2. Okay? So if I plug 1.9 in here, I get a positive value. And if I plug a 1.9 in here, I'm going to get a negative value. So overall, my value is going to be some sort of negative infinity or negative value. Okay. Now we're going to do it from the right side. So I have the limit as x approaches 2 from the right of 2x plus 5 over x minus 2. So if I put 2.1 in up here, again, I'm going to get a positive, and 2.1 minus 2 will be positive. So again, I'm getting a positive infinity. Now, because one is negative and one is positive, that means that they don't exist because they're not the same. Now, if they had been the same, we still can say do not exist. We just have a reason, negative infinity or positive. But in this case, they don't. So we would be writing this as the limit as x approaches 2 from the left of 2x plus 5 over x minus 2 equals the limit as x approaches 2 plus, does not equal, like this. Therefore, the limit as x approaches 2 of this function, 2x plus 5 over x minus 2, does not exist. That's a lot of writing, and I know we're all going to try to shortcut. I shortcut, but I've learned that when I'm shortcutting, we don't always learn how to go back and do it correctly. And on our AP test, for us to get those 3s, we have to be in the habit of doing it right from the beginning. So we're going to make sure that we're writing this out every time. And when I'm grading you, I'm going to be grading for these standards. Meaning if you just don't rewrite this out, I'm not going to give you credit. Okay, so let's make sure we're working on that every time. All right, let's do this guy over here. We'll try to squeeze him in, something a little bit different and simple. So again, I'm going to take the limit as x approaches 0 of 4. Well, that's 4. And the limit as x approaches 0 of x squared is 0. So we're going to have 4 over 0, or again, we're going to have a form that we need to keep doing a little bit of work on. So I'm going to say x equals negative 0.1 of the limit as x approaches 0 from the left of 4x squared. So when I square a negative, I get a positive, so I'm going to have a positive number there. Now, I'm not going to write the infinity part, I just know it's going to be positive, okay? Then I'm going to come from the other side, a positive 0.1, and I have the limit as x approaches 0 from the right side of 4x squared. And when I have a positive squared, I still get a positive overall. So in this case, this actually, we could say exists in the fact that it's going to infinity, but again, we're going to write it as does not exist with the reason of positive infinity. So we're going to have the limit as x approaches 0 from the left of 4 over x squared equals the limit of x going to 0 of 0 plus, and then 4 over x squared. And so our limit, or you can use your therefore sign, of x goes to 0 does not exist because of both are positive infinity. Okay, so that would be a fabulous answer. Again, notice all the times I wrote the word limit, we really want to be in that habit. Now, if we had continued on, which I recommend definitely doing and practicing, your value, when you went through here the first time, we would have found negative 4 over 0. Okay, then we have to do from the left. Okay, so if we did from the left, we're going to get a positive infinity. When we do it from the right, we're going to get a negative infinity, and therefore that does not exist. Now, again, I'm writing shorthand answers at this point. This is nowhere near acceptable work. You will get absolutely no credit for this. This is just to check yourself. Over here, we're going to find that it's actually an indeterminate form, 0 over 0. Okay, so then we're going to factor. So this is at the plug-in stage. Then we're going to factor. We're going to get negative 2 over 0. Then we're going to do the left and get a positive infinity, or sorry, a negative infinity. And when we go to the right, we're going to get a negative infinity. And we can say that, again, this does not exist. And we're going to say because of both are negative infinity. Okay, again, your correct form is in example 3A and 3B. These are just to check your own classwork. All right, best of luck when you work with these type of limits.